Today we're going to start looking at inequalities, and to be able to understand inequalities and what they are, we're going to start with just a real simple example of something that it is actually not an inequality, and then we'll show how that relates. So our first example, Michael has 12 pairs of Nikes. Write a number sentence to show how many pairs of Nikes Michael has. So we could represent that as Michael's Nikes equal 12. Because that's exactly how many pairs he has. He doesn't have more than 12. He doesn't have less than 12. He has exactly 12. Now, another example, and something that's a little different, using that same information, Jerry has more Nikes than Michael. So write a number sentence to show how many pairs of Nikes Jerry has. Well, if Michael has 12 and Jerry has more than that, then Jerry's amount has to be greater than 12. So that's an example of an inequality. It's when it doesn't tell us exactly what the number has to be, but it gives us sort of a range of what the numbers could be. So when we look at this, what that means is if Jerry's number of Nikes has to be greater than 12, that means Jerry could have 13 pairs of Nikes. He could have 2,000 pairs of Nikes. He could have 52 pairs of Nikes, 100 pairs of Nikes, 48 pairs of Nikes. We don't know exactly how many he has, but what we do know is it has to be greater than 12. So he can't have 4 or 7 or 9. He can't have any of those number of pairs of Nikes because he has to have a number that's greater than 12. So any number you can think of that's greater than 12 could be what Jerry has. So an inequality is different because it doesn't tell us exactly what the number has to be. It just gives us some rules for what the number could be. So in the first one, we know exactly how many Michael has. In the second one, we don't know how many Jerry has, but we do know that it's greater than 12. Another example of where you might see this is if you look at something like this. We see this a lot. You and your friends are going to Carowinds. You all want to ride the Intimidator. The sign at the ride says you must be at least 54 inches tall to ride. You are 54 inches tall. Kara is 53 and 5/10 inches tall. Cameron is 56 inches tall, and Michael is 52 inches tall. So who can ride? Well, it says you must be at least 58 inches tall to ride. Think about what that means. If you have to be at least 54 inches, then you have to be 54 or more, because 54 is the least you can be. So if the least you can be is 54 inches, then you are 54 inches. So you're good. So you can ride. Kara is 53 and 5/10 inches tall. That's not tall enough because it's less than 54 inches. Cameron is 56 inches tall, so Cameron can ride because Cameron is at least 56 inches tall. Remember, at least 54 inches tall. Remember, at least 54 inches tall is going to mean 54 inches tall or taller. And Michael is not going to be able to ride because Michael is 52 inches tall. So you and Cameron are going to get to ride while Kara and Michael get to go pick out something else to do. So let's look at inequalities and what the symbols are that we use for those. And this is something actually you've been using for a long time. You just may not realize you've been using it. So inequality. An inequality is a comparison of two quantities that are not necessarily equal. So we have some symbols we use for that. We have the greater than and less than symbols, which are probably ones you're already pretty familiar with. Some examples of the greater than symbol. 4 is greater than 2. M is greater than 3. Now notice, does that tell us exactly what M is? No, it doesn't tell us. If M is greater than 3, then we don't know what M is, but we do know M could be 7, 8, 20, 52, any number greater than 3. So any number greater than 3 is what M could be. If we look at less than, some examples of that, you guys are used to probably seeing 6 is less than 9. That's a pretty elementary inequality. If you look at something like r is less than 5, well, if r is less than 5, then that means that r could be 2, r could be 0, r could even be a negative number, -7. How about a mixed number? 3.5. It could be any number less than 5. That's what that inequality is saying. Now, there's some other inequality symbols we use. These might be new ones to you. We use greater than or equal to and less than or equal to. Those are just like the greater than and less than symbols. The difference is this line that's underneath of them. So the line that's underneath of them means they could be not only greater than a given number, they could also possibly, something could also be possibly equal to it. So for example, if x is greater than or equal to 9, then x could be, it could be 12 because that's greater than 9. It could be 15 because that's greater than 9. It could be 9 because that's equal to 9. Remember, it says x could be greater than or equal to 9. Our next inequality symbol is less than or equal to. So an example of that, h is less than or equal to 6. If h is less than or equal to 6, then h could be 5. H could be 5.9999 because that's still less than 6. And it could even be 6 because it says less than or equal to 6. So let's look at some examples here. Take a minute and see if you can sort these numbers and decide. It says if y is greater than 2, then y could be. Pause while you try to sort them and then see if you're correct. All right. So here are where our numbers would need to go. Notice all of the ones in the left column are all greater than 2. So even this one right here, which is 2.000001, that one is still greater than 2 because it's not much bigger than 2, but it is greater than 2. Looking at the ones that are no's, this one is close to 2, but it's not greater. And 2 is not greater than 2 either. It is less than 2. So those would still belong in the no category. All right, let's try another set. So if r is less than or equal to 4, then r could be. Take a moment to check try this and then check your work. All right, here are the correct sortings. Notice if r is less than or equal to 4, then 4 is less than or equal to 4, so it's okay to be in that category. All right, let's look at another one. If 7 is greater than x, then x could be. Try this one and see what you come up with. This one is a little tricky. Think about this for just a minute. If it says 7 is greater than x, think about putting each of these numbers over on this side where that x was. Is 7 greater than 4? Yes, it is. Is 7 greater than 0? Yes, it is. Is 7 greater than 6.876? Yes, it is. Is 7 greater than -3? Yes, it is. Is 7 greater than 5? Yes, it is. Now, if we look at those ones in the column that don't work, you might have thought that they would, but no, they don't, because is 7 greater than 7.002? No, it isn't. Is 7 greater than 7? No. Is 7 greater than 10? No, it's not. The thing that's confusing about this one is when it says 7 is greater than x, we have the x on the right-hand side. It would help you probably to flip that around. For most of us, it makes more sense to have the variable on the left-hand side than on the right. So we could flip that around and say if 7 is greater than x, then x is less than 7. And that would probably make more sense to you. Notice when I switch the variable and put it on the left-hand side, I have to also flip around the inequality symbol, and that makes sense because the pointy end of the inequality symbol was pointing at the x. So when I switch it, notice that the pointy end is still pointing at the x. So it's really important when your variable is on the right-hand side. In most cases, it's going to make more sense to you if you flip and put the variable on the left-hand side, but when you do, don't forget to flip the inequality symbol. All right, here are some phrases that you often see related to inequalities. Take a minute and read over those. Those should make sense. Those should be things that you've heard before. So for less than, some other words that mean that are fewer than, below, or under. For more than or greater than, we can think more than, above, over. Less than or equal to. These are get a little bit harder. At most, no more than, or the maximum. Greater than or equal to, at least, no less than, minimum. Those are ones people start to get mixed up because it sounds like when it says at least, that sounds like low, lower. But remember, that's just telling us what the lowest amount can be. So if I want something to be at least 20, for example, that means it has to be 20 or more. So you kind of have to really think about the words. Let's look at some examples. When we write an inequality to describe a situation, you want to think about this. What is it that's being described and what it's being compared to, and then figure out your inequality symbol, and that goes in the middle. So for our first example, vehicles must be shorter than 15 feet to travel under a bridge. Well, we are comparing, in this case, the height of the vehicle, and we're comparing it to 15 feet. And what does it say? Well, it says vehicles must be shorter than 15 feet. So that's going to mean they have to be less than 15 feet. So what might help you is to think about some numbers that are around 15 feet and think, can the vehicle be 14 feet tall? Can it be 15 feet tall? Can it be 16 feet tall? So think of one number that's less than, think of one number that's greater than, and think about the number itself. So could a 14-foot vehicle fit through? Yes, it could, because it's shorter than 15 feet. Can a 15-foot vehicle fit through? No, because it's not shorter than 15 feet. Could a 16-foot vehicle fit through? No, because it's not shorter than 15 feet. The next one, anyone over 65 may get a senior citizen's discount. So in order to get the discount, the age, it has to be compared to 65 years old. And it says anyone over 65. So let's think about it as a 64-year-old, a 65-year-old, and a 66-year-old. Is a 64-year-old over 65? Nope, they're not. Is a 65-year-old over 65? No, because they're exactly 65, not over it. Is a 66-year-old over 65? Yes. So we can only include people whose age is greater than 65. Next one, the elevator carries no more than 2,000 pounds. So we're talking about the weight that the elevator will carry, and we're comparing it to 2,000 pounds. So our number that we're looking at is 2,000. So let's think about a 1,999 pound load, a 2,000 pound load, and a 2,001 pound load. And you could come up with other numbers, but just one lower, one greater, and one that's exactly equal to what we're comparing to. So ask yourself, is 1,999, is it not more than 2,000? It's not more than 2,000. So that would work. How about 2,000? It is also not more than 2,000 pounds, so that would work. 2001, it is more than 2,000, so that wouldn't work. So the weight can be either greater than 2,000 or it can be equal to 2,000. It could be exactly 2,000. So greater than or equal to 2,000 is going to go there. Our last one, 90 pounds is the minimum weight to ride the zip line. So again, we're talking here about weight to ride the zip line, and we're comparing it to 90 pounds. And it says the minimum weight to ride is 90 pounds. So we're going to ask ourselves, well, can I be 89 pounds to ride? Can I be 90 pounds? Can I be 91? Well, it says the minimum, meaning the lowest, is 90. So can you be 80 pounds? Nope, because you're not, or 89 pounds? No, you're not big enough. 90 does meet the minimum. It's big enough. 91 is also big enough. So your weight has to be either greater than or equal to 90 pounds. Those are just some examples of where you see inequalities, and we see inequalities used a lot in real life. For example, if we see something that says you must be 40 inches tall, 48 inches tall to drive, 42 inches tall to ride, no riders under 42 inches, no exceptions. So we could come up with actually a lot of inequalities for this one. We could come up with your height to drive. It says you must be 48 inches tall to drive, so that means you must be 48 inches. You could be exactly 48 inches, and you could be greater than 48 inches. Your height to ride, so sometimes you're tall enough to ride, but not to drive. Your height to ride, it says you have to be at least 42 inches, but you could also be greater than 42 inches. No riders under 42 inches, no exceptions. So you couldn't ride if you were less than 42 inches. All right, the next one, weight limit of 10 tons. So that means that the greatest something can weigh, we usually see this going over a bridge or something like that. The greatest something could weigh is 10 tons. So we're looking at the weight. We're comparing it to 10 tons. And it says the weight limit. That means the maximum. So the maximum, the most, is 10 tons. So it could be equal to 10 tons, or it could be less than 10 tons. So if you got more than that, if you're carrying more than that, you better stay off the bridge. It's not going to work for you. You're going to fall. You're going to break the bridge. All right, next one. Maximum occupancy not to exceed 613 persons. We see this sometimes in a restaurant when they'll talk about how many people are allowed according to fire codes or something like that. So taking a look at this one. Not to exceed. That means not to go over 613 people. So the most number of people, or the number of people that can be there, has to be either equal to 613, or it can be greater. Or excuse me, not greater. That would be bad. It has to be not exceed. That means it has to be either less than 613, or it can be exactly equal to 613. And last but not least, prices starting at $750. We see this in stores, things like that, quite often. So the cost starts at $750. That means that is the lowest something might cost. So it could be exactly $750, or it could be greater than. So greater than, the cost is greater than or equal to $750. Let's look at one more thing about how so those are some examples, rather, of where we see inequalities used. Let's take a look at how we sometimes see this visually represented. We can graph an inequality, and when we graph an inequality, that means we're going to show what the values could be on a number line. And so the first thing, if we want to do that, is we have to draw a number line and label it. And then we're going to draw a circle around the target number, meaning the number that we're comparing to. We're going to leave the circle open if our value, our variable, has to be either less than that number or greater than that number. We're going to close it if it has to be, if it can be equal to it. And then we're going to draw an arrow to show what our solutions could be. So let's take a minute and talk about this. If let's say that we want to draw a picture of r being greater than or equal to 6. So if we want to do that, then we're going to need to show that 6 is the number that we're comparing to. And I usually label 2 numbers higher and 2 numbers lower. There's no rule that says it has to be that, but that's where I usually go, just so I know where my numbers are. I know which way my number line goes and all that stuff. So if I need r to be greater than or equal to 6, that means r can be 6. It can also be, well, can it be 4? No, because that's not greater than or equal. Can it be 5? No, because that's not greater than or equal to 6. It can be 6, which is shown with the closed dot. It can also be 7 or 8 or anything greater than that. So r could be any number greater than or equal to 6. So all the numbers greater than or equal to 6. Let's look at another example. If m is less than 4, then we're comparing m to 4. We're going to put some numbers that are greater than 4 and some numbers that are less than 4. It says m has to be less than 4. So can m be 4? No, it can't be. So I'm going to use an open circle because to show we're starting at 4, that's the number we're considering, but it can't actually be 4. And then think about what numbers work for that. Is 2 less than 4? Yes. Is 3 less than 4? Yes. Is 4 less than 4? No. Is 5 less than 4? No. And 6 is also not less than 4. So we need to point toward the 2 and the 3, the numbers that are less than 4. So M could be any number less than 4. Let's look at another example. H is less than negative 2. So if H has to be less than negative 2, then we're going to put negative 2 here. Remember, we're going negative 1, 0. As we go to the right, numbers get bigger, so we're getting closer to 0 as we go to the right. As we go to the left, the numbers are getting more negative. And it says H is less than negative 2. Thinking about that, numbers always get lower as they go to the left. So if we want numbers less than or lower than negative 2, we cannot include negative 2 because that's not less than negative 2. And we're going to go to the left because negative 3 and negative 4 are both less than negative 2. So H could be any number, or it includes all the numbers or any number less than negative 2. So that should give you a good idea of different ways we see inequality used in real life and how we can show those visually as well and determine what a number could be based on the inequality symbol.